Welcome back for the second half of proportional relationships. Today we're going to talk about a little bit more of the technical aspect of this, not so much the practical application where we find the area of, the height of like a flagpole or a pineapple or the height of the gym, but we're actually going to start talking about similarity as it pertains to perimeter and area. As you can see here, we have two right triangles, and this is a 3, 4, 5 right triangle, and this is a 6, 8, 10 right triangle. Those are two really great triangles to memorize as right triangles for standardized tests and things like that. That's a little bit extra information there. So let's talk about the similarity ratios. Well, what this is talking about is if we put all of the sides of these two triangles in relation to one another. So we make some ratios. We've got AB over DE is equal to BC over EF is equal to CA over FD. And if we look at what those actually are, they're going to be 1 over 2 because we have 5 over 10, 3 over 6, 4 over 8. So the similarity ratio of our sides is 1/2. It's important to note that we're going to be comparing these three things here. That's why we've put them in order like this. The perimeter ratio. Now the perimeter ratio is going to be the perimeter of triangle ABC over the perimeter of triangle DEF. When we do that, we end up with 12 over 24, which is equal to 1/2 again, right? And that makes sense because if each of the sides has a certain relationship, 1 over 2, 1 over 2, 1 over 2, that was our similarity ratio, it would make sense that if we just put all of them together, the ratio of the perimeter would be the same. When we look at the area ratio, though, we're really looking at area of ABC over area of DEF. And what that gives us is 6, because remember this is 1/2 of the base times the height, so 1.5 times 4 would be 6, and 1.5 times 6 would be 3, times 8 is 24, and that's 1 over 4. So really what we have here is equal to 1/2 squared. And that's our next theorem. Our theorem is the proportional perimeters and areas theorem. We use those two triangles as an example, but really this is true for all these figures. If the similarity ratio of two similar figures is A to B, so we find the similarity ratio. The ratio of their perimeters is A to B, so it's the same as the sides, and the ratio of the areas is A squared over B squared, or AB squared. Let's look at what this means for us in a practical example. Here's example 4. When we look at example 4, we're given that these two triangles are similar. So we want to find the perimeter of P and the area A of this big guy here. If we look at what this means, to find the similarity ratio, we already know that they're similar because we were given this. And so that means if I take this side, 16, and I put it over 20, I get the similarity ratio. I'm going to reduce that, and it's okay to reduce by 2's. If you don't know what goes into what already, just reduce by 2's. And I get down to something like this. So the area, or so the similarity ratio is 4 over 5. But I know that the perimeter ratio is also 4 over 5. And so here's what I'm going to do. I'm going to say, for the perimeter, I know that 4 over 5 is equal to the perimeter of the little one, so 36, over the perimeter of the big one. Okay? That's the perimeter of UWV. Okay? And so what I'm going to be doing here is 4x equals 5 times 36, that's 5 times 30, which is 150. 5 times 6 is 30, this is 180. So I divide by 4. And x is equal to 45 feet. So the perimeter of this one is 45 feet. Because 45 over 36 is equal to the same ratio as 20 over 16. Let's find area. I'm going to do area in blue. And area is going to be the ratio of the perimeters squared. So this is going to be 4 squared over 5 squared is 16 over 25. And so 16 over 25 is equal to 48 over the area of the big one. So 16a is equal to 25 times 48. When we do that out and divide by 16 on both sides, I get that 75 feet squared is the area. So let's review what we did. We found the similarity ratio in order to find our basis, because the similarity ratio is the basis for each of these measurements. Well, when I have the similarity ratio, I already have the perimeter ratio. And then I take it and set up a proportion with what I know the perimeter to be of the smaller one. That's what I did here. So the perimeter of the smaller one over x is equal to our perimeter ratio, right? I did the same thing with the area, except I know that a squared over b squared is equal to my area ratio, and I set that equal to what I know my area to be, and I go ahead and set it up from there. I've given you one down here at the bottom, and I'd like for you to try that one. So they're giving you the same information, they just haven't given you a picture. So ABC is similar to DEF, and we know the measurements. My hint for you: draw a picture. It will help you immensely. All right, thanks for watching, guys. We'll see you next time.